Hello, in this lecture we will find out the value of line segment MN. In the drawing we have square ABCD. We know that one side of square ABCD is equal to 12 units, that is to say AB equals to BC equals to CD equals to DA equals to 12 units, and inside the square we have a semicircle and a circle. The center of this circle is at point M and the center of the semicircle is at point N, and we want to find out the distance between the two centers of the length of line segment MN. We also know that the circle is tangent to the square at 2 points. This is one point of tendency and this is the second point of tendency between the circle and the square, and the circle is also tangent to AC at this point, and the semicircle is tangent to AC at this point, and the semicircle is tangent to the square at point D, and the semicircle touches side DC also at this point. Okay, I want to find out the length of line segment MN. So in the first step we'll define the point of tendency of tangent AB with this circle as point P. We'll define the point of tendency of tangent BC with this circle as point Q. This point is defined as point Q. We will define the point of tendency of tangent AC with this circle as point R. We also will define the point of tendency of tangent AC with this semicircle as point S. And we will define the touching point of the semicircle with side DC, this point as point T. And we also will define the length of line segment PB as A, that is to say PB equals to A units in its length. So we know that AB equals to 12 units and PB equals to A, so AP equals to AB minus PB, that is to say AP will be equal to AB, that is 12 units, minus PB, that is A. In conclusion, we found out that AP equals to 12 minus A units in its length. And in the next step I will present to you a new rule that is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number one? The meaning of rule number one is that if we have this circle and we also have this point P, is an external point in relation to this circle. Why point P is an external point? Because point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point in relation to this circle. So if from the external point P we will draw two tangents to this circle. So here the first tangent the point of tangency of the first tangent with this circle will be defined as point A. It is the touching point or the point of tangency of the first tangent with this circle, and we will draw a second tangent to this circle from point P, of course. And we will define the point of tangency of the second tangent with this circle as point B. So according to rule number one, the lengths of two tangents, that is to say, the length of the first tangent is PA, and the length of the second tangent is PB. So according to rule number one, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P to a circle, to points A and point B, are equal. That is to say PA equals to PB according to rule number one. So whenever you draw two tangents to a circle from a common external point, point P, to points A and B, then the lengths of those two tangents are equal to each other. That is to say PA is equal to PB. Okay, so we actually can implement rule number one in our drawing. We will relate to the external point, point B. Actually, at point B is an external point in relation to this circle. And from the external point B, we have two tangents to this circle. The first tangent is tangent BP, and the second tangent from point B is BQ. And according to rule number one, BP is equal to BQ. I'll repeat again. According to rule number one, BP is equal to BQ. But according to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. BQ is also equals to A. So we can write here that BQ equals to A units. And because of the fact that BQ is equal to A units, the length of line segment CQ will be equal to BC, that is 12 units, minus BQ, that is A. In conclusion, QC will be equal to 12 minus A units in its length. So, in the next step, we will focus on point A. Point A is an external point in relation to this circle. So from the external point, point A, we have two tangents to this circle. We have tangent AP. This is the first tangent. And we also have tangent AR to this circle. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AP is equal to AR according to rule number 1. But we have already found out that AP equals to 12 minus A. AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we will derive that AR is also equals to 12 minus A. AR is equal to 12 minus A. Here we can write down that AR equals to 12 minus A units. And we'll continue to focus on point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AS, and the second tangent to this semicircle is AD. The point of tendency is at point D, and here the point of tendency of AS is at point S. And according to rule number 1, AS is equal to AD. I repeat again, according to rule number 1, AS equals to AD. Okay? But, so we know that according to rule number 1, AD equals to AS. But according to what is given us in the question, AD equals to 12 units. Okay, AD equals to 12 units. From this equation, 12 equals to AD equals to AS. We will conclude that AS is also equals to 12 units. So we can write down here that AS, line segment AS, is equal to 12 units. And because of the fact that AS equals to 12 units, we can calculate the value of line segment RS. From the drawing, it is very simple to see that the length of line segment RS, it is actually equal to AS minus AR. Okay, RS equals to AS minus AR, so RS, again, RS, line segment RS equals to AS minus AR, but we have already found out that AS equals to 12, AR equals to 12 minus A. So, in conclusion, we found out that RS equals to 12 minus 12 minus A. We will open the brackets here, and we will get that 12 minus 12 is 0, minus and minus is plus, so we found out that RS equals to A. Line segment RS equals to A. So we can write here that RS equals to A. In the next step, we will focus on point C, the external point C. Point C is an external point in relation to this circle. So from point C, from the external point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent is tangent CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, according to rule number 1, CQ is equal to CR, but we have already found out that CQ is equal to 12 minus A. CQ equals to 12 minus A. From this equation, 12 minus A equals to CQ equals to CR, we will derive that CR is also equals to 12 minus A. So we found out that CR, line segment CR, is equal to 12 minus A units. So in the next step, I will present to you a new, but before that, we will calculate the value of line segment SC or CS. The value of line segment SC, this line segment, is equal to RC minus RS. It's very simple to see that the value of the length of line segment SC is equal to RC minus RS. So the value of line segment SC equals to RC, that is 12 minus A, minus minus RS, that is A. So in conclusion, we found out that the value of line segment SC is equal to 12 minus A. That is to say, it equals to 12 minus A. So we found out that the value of line segment SC is equal to 12 minus 2A. 12 minus 2A. So we can write here that SC equals to 12 minus 2A. In the next step, I will present to you a new rule, rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point, point O, and we also have tangent AB to this circle, this is tangent AB. Tangent AB is tangent to this circle at this point. We'll define this point as point M. Point M is the point of tendency of tangent AB with this circle. We will join points O and M together by a straight line. Line segment OM is the radius of this circle because of the fact that it starts from point O, that is the center of this circle, and ends at point M, that is a point on this circle itself. Therefore, and this is exactly the definition of a radius. Therefore, OM is the radius of this circle, so we will define it as R. So here we have the radius of this circle, that is OM, that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. AB is perpendicular to MO, that is to say, this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees. Again, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB perpendicular to the radius MO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So we can implement rule number 2 in our drawing. Here we will join points M and P together by a straight line. Line segment MP is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and ends at point P, that is the point of this circle itself. So the radius MP is drawn to the point of tendency, that is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius, that is to say, the tangent AB will be perpendicular to the radius PM. So AB is perpendicular to PM, that is to say, according to rule number 2, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we also know that all the angles inside the square are right angles, therefore angle ABC will be equal to 90 degrees. It's one angle out of 4 angles that are inside square ABCD, therefore it is a right angle. We join points M and Q together by a straight line. Again, here MQ, line segment MQ is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and ends at point Q, that is the point on this circle itself. Therefore, MQ is the radius of this circle, and we have the radius MQ that is drawn to the point of tendency, that is to say, the radius is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, in this case, the tangent BC will be perpendicular to the radius QM. BC is perpendicular to QM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So actually here, in quadrilateral PBMQ, we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3 is 270 degrees. So here, 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we'll get that angle PMQ is equal to 360 degrees minus 270 degrees, it is 90 degrees. So we found out that angle PMQ is equal to 90 degrees. This angle is a right angle. Therefore, in quadrilateral PBMQ, we have four right angles, 1, 2, 3, 4. Any quadrilateral that has four right angles must be at least a rectangle. So we will relate to quadrilateral PBMQ as a rectangle. Quadrilateral PBMQ is a rectangle. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. I read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So actually, in rectangle PBMQ, according to rule number 3, we will get that PB equals to MQ. PB equals to MQ. But according to our definition, PB equals to A. And from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. MQ equals to A. Likewise, PM equals to BQ, according to rule number 3. But we've already found out that BQ equals to A. So from this equation, PM equals to BQ equals to A, we will derive that PM is also equals to A. So here PM equals to A, so we found out that quadrilateral PBMQ is a square. Okay? In the next step, we'll define the radius of the semicircle as B. Here, dn is the radius of the semicircle, because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point D, that is a point on the semicircle itself. Therefore, dn is the radius of the semicircle. Therefore, it equals to B, according to our definition. And T is also the radius of the semicircle because of the fact that it starts from point N, that is the center of the semicircle, and ends at point T, that is a point on this semicircle itself. Therefore, NT is the radius of the semicircle, that is to say it is also equals to B units. And what is the value of line segment TC? From the drawing, it is very easy to see that the value of line segment TC is equals to DC, DC minus DN minus NB. I will repeat again, the value of the length of line segment TC is equal to DC minus DN minus NB, but we know that DC equals to 12 units and DN equals to B and NB is also equals to B. So in conclusion, we found out that TC equals to 12 minus B. That is to say TC equals to 12 minus 2B. So I can write down that TC equals to 12 minus 2B. Here. In the next step, we will join points N and S together by a straight line. Line segment NS is the radius of the semicircle because of the fact that line segment NS starts from the center of the semicircle, that is to say from point N, and ends at point S, that is a point on the semicircle itself, and this is exactly the definition of a radius. Therefore, NS is the radius of the semicircle, that is to say it equals to B units. So here, the radius NS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to SN. Again, AC is perpendicular to SN, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. So actually, the green triangle S and C is a right triangle because of the fact that angle NSC is equal to 90 degrees. So we will implement the Pythagoras, but because, before we do it, actually we will calculate the value of diagonal AC. What is the value of diagonal AC? The length of diagonal AC. The length of diagonal AC, you can see it from the drawing, that AC is equal to AR plus RC. AR plus RC. I will repeat again. The diagonal AC equals to AR plus RC. So AC equals to AR, when we already found out that AR equals to 12 minus A, plus RC. We have already found out that RC equals to also 12 minus A. So AC equals to 12 minus A plus 12 minus A. That is to say AC equals to 12 plus 12, that is 24. Minus A plus minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. In the next step, we will focus on the right triangle, triangle ABC. We will implement the Pythagoras theorem on the right triangle, triangle ABC. So according to the Pythagoras theorem, on the right triangle, triangle ABC, here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle ABC is AC, so the square of the hypotenuse is AC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus BC square. I'll repeat again, according to equation number 1 in Pythagoras theorem, in the triangle ABC, AC square equals to AB square plus BC square. We have already found out that AC equals to 24 minus 2A. So AC square will be equal to 24 minus 2A square, and it equals to AB square. AB is 12, so AB square is 12 square, plus BC square. BC is also equals to 12 square, so BC square is 12 square. So in conclusion, we found out that according to equation number 1, (24) minus 2A square is equal to 12 square plus 12 square. 12 square plus 12 square is 2 times 12 square. Here we'll take out of this equation, equation number 1, and we will get that according to equation number 1, 24 minus 2A is equal to the square root of 2 times 12. Why? Because we have here 2, so when we took root, it will be square root of 2, and we have also 12 square, and when we will take root from the 12 square, the square will cancel the root, and we're left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to square root of 2 times 12. So here we will add to this equation, equation number 1, 2A, and we will subtract square root of 2 times 12, and we will get that according to equation number 1, (2A) equals to 24 minus square root of 2 times 12. I will repeat again. We know, according to equation number 1, we found out that 24, 2A equals to 24 minus square root of 2 times 12. We will divide the equation number 1 by 2, and we will get that A, that is actually the radius of the circle, is equal, according to equation number 1, A equals to 24 over 2 is 12, minus 12 over 2 is 6. So in conclusion, we found out that according to equation number 1, A equals to 12 minus 6 times square root of 2. Okay? In the next step, we will focus on the green right triangle NSC. On the green right triangle NSC, according to Pythagoras theorem, but before we will implement the Pythagoras theorem on the right green triangle NSC, we will calculate the value of the hypotenuse that is actually NC. What is the length of the hypotenuse NC? The length of the hypotenuse NC, it will be equal actually to NC equals to NT plus TC. NT plus TC. So NC equals to NT, that is B, the radius of the semicircle, plus TC, that is equal to 12 minus 2B. So in conclusion, we found out that NC is equals to 12, B minus 2B is minus B, so it is actually equals to 12 minus B. Okay, now we will implement the Pythagoras theorem on the right green triangle, triangle NSC. This will be a question number 2. According to question number 2, the square of the hypotenuse, that is to say NC square, it is actually NC square equals to the sum of the squares of the perpendiculars, that is to say it equals to NS square plus SC square. I repeat again, in the right triangle, triangle NSC, according to the Pythagoras theorem, NC square equals to NS square plus SC square. But we have already found out that NC equals to 12 minus B. So NC square will be equal to 12 minus B square. And it equals to NS square. NS equals to B, so NS square will be equal to B square plus SC square. SC equals to 12 minus 2A, so SC square will be equal to 12 minus 2A square. In the next step, we will find out the value of the expression 12 minus 2A. 12 minus 2A, it is actually equals to 12 minus 2 times A, and we have already found out that A equals to 12 minus 6 times square root of 2. So in conclusion, 12 minus 2A equals to 12 minus 2 minus 12 is minus 2 times minus 12 is minus 24. Minus 2 minus 6 is plus 12. So it is actually equals to 12 times square root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that the value of the expression of 12 minus 2A, it is actually equals to 12 times square root of 2 minus 12. Okay, therefore, we can substitute 12 minus 2A in equation number 2 here by 12 times square root of 2 minus 12. We will do it now, and we will get that according to equation number 2, first of all, we have here 12 minus B squared. The value of 12 minus B squared is actually equals to 12 squared plus b squared minus 2 times 12 times b, that equals to b squared plus 12 minus 2a, and we have already found out that 12 minus 2a, it is actually equals to 12 times square root of 2 minus 12. Okay? Here it is square, so we'll square it also. So in equation number 2 we have b squared on both sides of the equation, so b squared will get cancelled. And what is left after we cancel b squared from equation number 2? What is left? It is actually 12 squared minus 2 minus 12 is minus 24b. That equals, here we will take 12 as a common factor out of this expression, and inside the brackets we will have here square root of 2 minus 1 all squared. So we have here 12 squared minus 24b, that equals to, so it is, we have square on both, on 12 and also on square root of 2 minus 1, so here we will open the, we will imply the square on both the expressions, so here will be 12 squared times square root of 2 minus 1, that is also square. According to the rule that the square root of xy in the power of n is equal to the square root of x n times square root of yn. According to this rule, the square root of this expression equals to 12 squared times square root of times square root of 2 minus 1 squared. Okay. Here we will open the brackets and we'll get that according to equation number 2, 12 squared minus 24b equals to, here we have 12 squared, and the value of square root of 2 minus 1 squared equals to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1, so we got, according to equation number 2, that 12 squared minus 24b, here we will open the brackets and we get 2 times 12 squared is 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. So here we have 12 squared on both sides of the equation, so 12 squared will get cancelled. What is left from equation number 2 after we cancel 12 squared? What is left? It is actually here we have minus 24b equals to 12 squared is 144. 144 times 2 is 288. Here we have 12 squared is 144. 144 times minus 2 is minus 188. Minus 288 times square root of 2. Here we will divide equation number 2 by 24, and we'll get that according to equation number 2, minus 24b over 24 is minus b, that equals to 288 over 24 is 12, and minus 288 over 2 is minus 12, so it is minus 12 times square root of 2. We will multiply equation number 1 by minus 1. We'll multiply equation number 2 by minus 1, and we'll get that according to equation number 2, the value of b, that is the radius of the semicircle, is equal to 12 times square root of 2 minus 12. We found out the value of b, that is the radius of the semicircle, and we have already found out the value of a, that is also the radius of the circle. A equals to 12 minus 6 times square root of 2. And what is the value of a plus b? It is very easy to see from the drawing, from the equations, that a plus b, here we have minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. In the next step, we will join points M and R together by a straight line. MR is the radius of the circle because of the fact that line segment MR starts from the center of the circle, that is to say from point M, and ends at point R, that is a point on the circle itself. Therefore, this is exactly the definition of a radius. Therefore, MR is the radius of this circle, that is to say it equals to a units. So here we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius Rm. Again, AC is perpendicular to Rm, that is to say this angle is equal to 90 degrees, and this angle is also equal to 90 degrees according to rule number 2. In the next step, from point M, we will draw perpendicular on Rm. Okay? So from point M, we draw perpendicular on Rm, that is to say this angle is equal to 90 degrees. And we will extend the radius NS by a straight line. Until it intersects with the perpendicular from point M, and we will define the intersection point of the extended NS and the perpendicular from point M as point X. Point X is the intersection point between the extended NS and the perpendicular from point M. NS is the radius of the semicircle that equals to B, therefore it is absolutely a straight line. NS is a radius, it must be a straight line, and we actually extended the straight line NS by a straight line. And when you extend a straight line by a straight line, what you will get, it is actually also a straight line. So actually we got line segment NX that is actually also must be a straight line, because when you extend a straight line by a straight line, it still be a straight line. The result will be also a straight line. So NX is a straight line. We can write down that NX is a straight line. Line segment NX is a straight line. We actually have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. I read rule number 4 again. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So we will focus on the straight line NX. Actually, on the upper side of the straight line NX, if you focus on the upper side of the straight line NX at point S, then according to rule number 4, the sum of its angles on the upper side at point S must be equal to 180 degrees. So which angles we have on the upper side of the straight line NX at point S? We have here 90 degrees, and we have also angle RSX. So 90 degrees plus the size of angle RSX, in total they must be equal to 180 degrees according to rule number 4. Okay? So here we will subtract 90 degrees from this equation, and we will get that the size of angle RSX is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle RSX is equal to 90 degrees. This angle RSX is a right angle, is equals to 90 degrees. In quadrilateral RMSX, we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is 270 degrees, plus the size of the 4th angle, that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we will get that the value of angle MXS, or the size of angle MXS, is equal to 360 degrees. 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that the size of angle MXS is equal to 90 degrees, that is to say it is a right angle. So here, angle MXS is a right angle, so we actually found out that all the angles inside quadrilateral RMSX are right angles. It has 4 right angles. Therefore we can write down that quadrilateral RMSX is at least a rectangle if not a square. Why? Because it has 4 right angles. We write down that quadrilateral RMSX that has 4 right angles is at least a rectangle. But we know that the opposite sides of a rectangle are equal to each other according to rule number 3. That is to say, the opposite sides of rectangle RMSX are equal to each other. That is to say, RM is equal to SX according to rule number 3. But we have already found out that Rm equals to A. It is the radius of the circle. Rm equals to A. So from this equation A equals to Rm equals to Rx, we will conclude that Sx is also equals to A. Here we can write down that Sx equals to A. Likewise, in rectangle RMSX, Rs must be equal to Mx. Rs must be equal to Mx according to rule number 3. Rs equals to Mx. But we have already found out that Rs equals to A. So from this equation A equals to Rs equals to Mx, we will conclude that Mx is also equals to A. Mx is also equals to A. Here Mx equals to A. And because of the fact that angle MXN is a right angle, triangle MXN is a right triangle, and we will implement the Pythagoras theorem on the orange right triangle, triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse of the right orange triangle, triangle MXN is Mn, and the square of the hypotenuse is Mn squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to mx squared plus xn squared. I'll repeat again. In the right triangle, triangle MXN, according to the Pythagoras theorem, PT, Mn squared equals to Mx squared plus Xn squared. So Mn is the missing variable, so we leave it as it is. And it equals to Mx squared. Mx equals to A, so Mx squared will be equal to A squared plus xn squared. Xn equals to a plus b, so xn squared will be equal to a plus b squared, and it equals to mn squared. So, in conclusion, according to equation 3, number 3, we found out that a squared plus a plus b squared equals to mn squared. We have the values of a and a plus b. Therefore, we will substitute a by the value of a, and we will substitute a plus b by the value that we found for a plus b. We will do it now, and we will get that we already found out that a equals to 12 minus 6 times square root of 2 square plus a plus b square. We have already found out that a plus b square, that a plus b equals to 6 times square root of 2, therefore a plus b square will be equal to 6 times square root of 2 square, and all equals to mn square according to equation number 3, and according to Pythagoras theorem also. We will open the brackets here in equation on this side of equation number 3, and we will get that according to equation number 3, 12 minus 6 times square root of 2 square equals to 12 square plus 6 times square root of 2 square. 6 times square root of 2 square equals to 6 square, that is 36, times square root of 2 square. Square root of 2 is 2, and 2 times 36 is 72. Plus, we already found out that 6 times square root of 2 square is 72. And here we have also to subtract minus 2ab, that is actually minus 2 times 12 times 6 times square root of 2. All equals to mn squared. Twelve squared is 144. 72 plus 72 is also 144. 144 plus 144 is 2 times 144 minus 6 times 2 is 12. 12 times 12 is 144. So this expression equals to, in conclusion, to 144 times square root of 2, and all equals to mn squared. Here we take 144 as a common factor from those two expressions, and we will get that after we took 144, what is left from this expression? What is left? It is actually 2. What is left from this expression after we took from it 144 is a common factor? What is left? It is actually minus square root of 2, and all equals to mn squared. Mn squared. Here we'll take a root out of this equation, equation number 3, and we'll get that according to equation number 3, the square root of 144 is 12, and we have also here the square root of 2 minus square root of 2. That is actually equals to mn. So the answer to the question is that the value of line segment mn, that is also actually the distance between the centers of the circle and the semicircle, is equals to 12 times square root of 2 minus square root of 2, or in terms of numbers, it's 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 1.18 units. Okay, this is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the distance between the center of the semicircle that is at point N and the center of this circle that is at point M. We want to find out the value of line segment MN or NM. It is the same. And we have here square ABCD. One side of square ABCD is equal to 12 units. Inside the square we have a semicircle that is center is at point N, and we have a circle that is point M, that is center is at point M. And we want to find out the distance between the centers of the semicircle and the circle, that is to say, we want to find out the length of line segment MN. So first of all, we defined the point of tendency of tangent AB with the circle as point P. We defined the point of tendency of tangent BC with this circle as point Q. We defined the point of tendency of tangent AC with this circle as point R. We also defined the point of tendency of tangent AC with this semicircle as point S, and we defined the touching point of the semicircle with DC as point T. And then we also defined line segment PB as A, that is to say, according to our definition, PB equals to A units in its length. Then I presented to you whole, actually here, if PB equals to A and AB equals to 12, then AP will be equal to AB minus PB, that is to say, AP will be equal to AB, that is 12, minus PB, that is A. In conclusion, AP equals to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of those, the length of two tangents from a common external point to a circle are equal. So we have this circle and we have external point P, and from the external point P we draw two tangents to this circle. The first tangent is tangent PA. The point of tendency of the first tangent with this circle is at point A, and the second tangent that we draw is tangent PB, and the point of tendency of the second tangent with this circle is at point B. And according to rule number 1, the lengths of two tangents, that is to say, AP is the length, or PA is the length of the first tangent, and PB is the length, or PB is the length of the second tangent. So the length of two tangents from a common external point, the common external point is point B, to a circle, 2 points A and B are equal. That is to say, PA equals to PB. So whenever you draw from a common external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this case, PA is equal to PB. Okay, so we can implement rule number 1 in our drawing. Here we have the external point B, and from the external point B we have two tangents to this circle. The first tangent is BP, the second tangent is BQ, and according to rule number 1 they are equal to each other. Okay, here we have the first tangent is BP, the second tangent is BQ, and according to rule number 1 they are equal to each other, but we have, according to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. So here we can write down that BQ is also equals to A units in its length. So if BQ equals to A, then QC will be equal to BC minus BQ. That is to say, QC will be equal to BC, that is 12, minus A, that is minus BQ, that is A. So in conclusion, QC equals to 12 minus A. Then we focus on point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent to this circle is tangent AR. And according to rule number 1, they are equal to each other. That is to say, AP equals to AR. But we have already found out that AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR. We will conclude that AP is also equals to 12 minus A. Okay, we continue to focus on point A. For the external point A, we have two tangents to the semicircle. The first tangent is tangent AD. Tangent AD is tangent to the semicircle at point D. Point D is the point of tendency. And we have the second tangent, that is tangent AS. Tangent AS is tangent to the semicircle as point S. At point S is the point of tendency. And according to rule number 1, the lengths of those two tangents from a common external point A are equal to each other. That is to say, AD equals to AS. Yeah. Or AS equals to AD according to rule number 1. But according to what is given us the question, AD is one side of square ABCD, and we know that all the sides of square ABCD are equal to 12 units. Therefore, AD equals to 12 units. So from this equation, 12 equals to AD equals to AS, we will conclude that AS is also equals to 12 units. So we can write here that AS equals to 12 units. So what is the value of RS? It is very easy to see from the drawing that AS equals to, what is the value of RS, line segment RS? It is very easy to see from the drawing that the value of line segment RC, or the length of line segment RS, is equal to AS minus AR. Okay? The value of line segment RS equals to AS minus AR. We have already found out that AS equals to 12, and we have already found out that AR equals to 12 minus A. So in conclusion, RS equals to 12 minus 12 minus A. We open the brackets and we got that RS equals to 12 minus 12, that is 0, minus and minus is plus. So we found out that RS equals to A units. Okay, then we focus on point C. From the external point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent is tangent CR. And according to rule number 1, the lengths of those two tangents must be equal to each other. That is to say, CQ equals to CR according to rule number 1, but we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR. We will conclude that CR is also equals to 12 minus A. So we can write here that CR equals to 12 minus A. Okay, then we found out the value of line segment SC. What is the value of line segment SC? It is very easy to see that SC is equal to RC minus RS. Again, RC minus RS equals to SC. Okay, here SC equals to RC minus RS. So SC equals to RC. RC, we already found out that RC equals to 12 minus A. And we have already found out that RS equals to A. So in conclusion, we found out that SC equals to 12 minus A minus A. 12 minus A minus A is equals to 12 minus 2A. So in conclusion, we found out that the value of the length of line segment SC is equal to 12 minus 2A. Okay? Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we have here this circle, and the center of this circle is at this point, point O, and we have tangent AB that is tangent to this circle at this point, point M. Point M is the point of tendency of tangent AB with this circle. OM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is a point on this circle itself. Therefore, OM is defined as the radius of this circle. And we have the radius OM that is drawn to the point of tendency, that is to say OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We can actually implement rule number 2 in our drawing, because in our drawing, first of all, we join points M and P together by a straight line. MP, line segment MP is the radius of the circle because of the fact that it starts from the center of the circle and ends at point P, that is the point of this circle itself. Therefore, MP is the radius of this circle. And we have the radius of this circle MP that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. So whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius PM, AP perpendicular to PM. It means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. And because of the fact that all the angles inside the square are right angles, angle ABC will be equal to 90 degrees. And we join points M and Q together by a straight line. MQ is the radius of this circle for the same reason. It starts from the center of the circle and ends at point Q, that is a point on this circle itself. Therefore, MQ is the radius of this circle. And we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius, that is to say the tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM. It means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to rule number 2. So in quadrilateral PBMQ we have 3 right angles. The sum of 3 right angles is 1, 1, 2, 3. The sum of 3 right angles is equal to 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we subtracted 270 degrees from this equation and we got that angle PMQ is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. This angle is a right angle. So therefore quadrilateral PBMQ that has 4 right angles must be at least a rectangle. Quadrilateral PBMQ is at least a rectangle, and we have rule number 3 that the opposite sides of a rectangle are equal to each other. So in rectangle PBMQ, the opposite sides are equal to each other, that is to say PM equals to MQ, PB is equal to MQ, but PB equals to A according to our definition. So from this equation A equals to PB equals to MQ, we will conclude that MQ is also equals to A. Here MQ equals to A, so we actually found out that the radius of the circle is equal to A units. Likewise, BQ must be equal to PM according to rule number 3. Or PM equals to BQ according to rule number 3. But we have already found out that BQ equals to A. So from this equation, PM equals to BQ equals to A, we will conclude that PM is also equals to A. So actually we found out that PBMQ, quadrilateral PBMQ, is not a rectangle but a square. what is the value in the next step? We defined the radius of the semicircle as b, so dn equals to b, and b and t is also equals to b. It's the radius of the semicircle. And what is the value of tc? It is very easy to see from the drawing that tc equals to dc minus dn minus nt. Okay, tc equals to dc minus dn minus nb minus tc equals to dc minus dn minus nt. This is actually minus nt minus nt. So actually found out that tc equals to dc, that is 12, minus dn, that is b, and minus nt, that is also b. In conclusion, we found out that line segment tc equals to 12 minus 2b. And what is the value of AC? The value of diagonal AC is equal actually to AR plus RC. Okay, AC equals to AR plus RC. And we have already found out that AR equals to 12 minus 8, RC is also equals to 12 minus 8. So in conclusion, AC equals to 12 minus 8 plus 12 minus 8. 12 plus 12 is 24. Minus a plus minus a is minus 2a. So in conclusion, we found out that AC equals to 24 minus 2a. Then we focused on the right triangle, triangle ABC. Triangle ABC is the right triangle because of the fact that triangle ABC is equal to 90 degrees. So in the right triangle, triangle ABC, according to the Pythagoras theorem, the slope of the hypotenuse equals to the sum of the slopes of the perpendiculars. That is to say, AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. We already found out, or we just right now found out, that AC equals to 24 minus 2a. Therefore, AC square will be equal to 24 minus 2a square. And it equals to AB square. AB is 12, so AB square is 12 square, plus BC is square. BC is 12, so BC square is 12 square. So 12 square plus 12 square is 2 times 12 square. So in conclusion, we found out that going to equation number 1, 24 minus 2a square equals to 2 times 12 square. We took the root of this equation, equation number 1, and we found out that 24 minus 2a equals to the square root of 2 times 12. Why times 12? Because the square root of 12 square is 12, because the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2a equals to the square root of 2 minus the square root of 2 times 12. Okay, so here we added to this equation, equation number 1, 2a, and we subtracted square root of 2 times 12, and we found out that according to equation number 1, 2 times a equals to 24 minus square root of 2 times 12. We divided equation number 1 by 2 and we got that a equals to 24 over 2 is 12 and minus 12 over 2 is minus 6. So in conclusion, we found out that a, the radius of the circle, equals to 12 minus 6 times square root of 2 units. Then we focus on the green right triangle, triangle NSC. But first of all, we found out the hypotenuse NC of the right triangle NSC, the right green triangle NSC. NC equals to NT plus TC. But NT equals to B and TC equals to 12 minus 2B. So in conclusion, we found out that NC equals to 12 and B minus 2B is minus B. So in conclusion, we found out that NC, the hypotenuse of the green right triangle NC, is equal to 12 minus B. So according to equation number 2 in the Pythagoras theorem, the square of the hypotenuse is NC square and it must be equal to NS square plus SC square. nc equals to 12 minus b, so nc squared will be equal to 12 minus b squared, and it equals to ns squared. Ns is equal to b, so ns squared, it will be equal to b squared plus sc squared. Sc equals to 12 minus 2a, so sc squared will be equal to 12 minus 2a squared. So here we found out the value of 12 minus 2a. What is the value of 12 minus 2a? 12 minus 2a equals to 12 minus 2 times a, and a is equal to 12. A is equal to, here a is equal to 12 minus 6 times square root of 2. So here it is 12 minus square root of times 6 times square root of 2, that is actually a. Here we open the brackets and we got that 12 minus 2 times minus 12 is minus 24, and minus 2 times 6 is minus 2 minus times 6 is 12. So in conclusion, we found out that this expression equals to 12 minus 24 plus 12 times square root of 2. 12 minus 24 is minus 12 plus 12 times square root of 2. So in conclusion, we found out that 12 minus 2a is equal to 12 times square root of 2 minus 12. So we can substitute 12 minus 2a in equation number 2 by 12 times square root of 2 minus 12. We did it. Here we substituted 12 minus 2a by 12 times square root of 2 minus 12 squared. And we also open the brackets here. 12 minus b squared is equal to 12 squared plus b squared minus 2 times 12 times b, and it equals to b squared plus 12 times square root of 2 minus 12 squared. Here we have b squared on both sides of the equation, so b squared will get cancelled, and we got that 12 squared minus 24b equals to 12. We took 12 as a common factor out of this expression. So inside the brackets we will have square root of 2 minus 1 all squared. So here we have 12 squared minus 24b, that equals to, according to the rule that hy to the power of n is equal to x to the power of n times y to the power of n, then the value of this expression will be equal to 12 squared times square root of 2 minus 1 squared. Okay, then we have here 12 squared minus 24b, that equals to 12 squared, and the value of square root of 2 minus 1 squared is square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. Here we have 12, so here we got that 12 squared minus 24b equals to, we open the brackets here, 12 squared times 2 is 2 times 12 squared, 12 squared times 1 is 1 times 12 squared, and we have also 2 times square root of 2 times 12 squared. We have 12 squared on both sides of the equation, so 12 squared will get cancelled, and we left only with minus 24b, that equals to, here 12 squared is 144, 144 times 2 is 288. Here we have minus 2, 12 squared is 144, and 144 times minus 2 is minus 188 times square root of 2. So here we divided equation number 2 by 24, and we got that minus b equals to 288 over 24 is 12, and minus 288 over 24 is minus 12. Here we have also square root of 2. We multiplied equation number 2 by minus b, and we found out that according to equation number 2, b equals to 12 times square root of 2 minus 12. We have already found out that a equals to 12 minus 6 times square root of 2, And what is the value of a plus b? You can see it is very easy to see from those two expressions that a plus b will be equal to, here we have minus 12 plus 12, that is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. So here we actually joined points M and R together by a straight line. MR is the radius of this circle because of the fact that it starts from the center of the circle, and then that point R, that is the point on this circle itself. And this is exactly the definition of the radius. So MR is the radius of this circle, that is to say it equals to A. And we have the radius of this circle MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, in this case, the tangent AC will be perpendicular to the radius RM. AC perpendicular to RM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, from point M, we drew perpendicular on RM. On RM, we drew perpendicular from point M, so this angle equals to 90 degrees. And then we extended NS. We extended the radius NS in such a way that it intersects with the perpendicular from point M, and we define the intersection point between the extended NS and the perpendicular from point M as X. Okay, NS is the radius of the semicircle, therefore it is absolutely a straight line. And then after we extended the straight line NS by a straight line, we still got a straight line. When you extend a straight line by straight line, you still will have, the result will be a straight line. So the result of the extension is NX, and NX must be still a straight line. So we can write down that NX is a straight line. When you extend a straight line by a straight line, it must be still a straight line. So NX is a straight line, and we have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on the upper side of the straight line NX, if we focus on the upper side of the straight line NX at point S, then the sum of the angles must be equal to 180 degrees according to rule number 4. Which angle we have in the upper side of NX at point S? We have here 90 degrees plus angle RSX. So 90 degrees plus angle, the size of angle RSX, in total they must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that angle RSX equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle RSX, is a right angle. It equals to 90 degrees. So here we have 1, 2, 3 right angles. In quadrilateral RMSX, we have 3 right angles, and the sum of 3 right angles is 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle MXS is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle MXS is equal to 90 degrees. Therefore, we actually found out that in quadrilateral RMXS, all the angles inside it are right angles. Quadrilateral RMSX has 4 right angles. Therefore, quadrilateral RMSX that has 4 right angles must be at least a rectangle. For the other one, RMSX with 4 right angles must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle RMSX are equal to each other. It means that RM is equal to SX. Here Rm is equal to Sx according to rule number 3. But we have already found out that Rm is equal to A. It is the radius of the circle. So from this equation A equals to Rm equals to Sx, we will derive that Sx is also equals to A. So we can write here that Sx is equals to A. Likewise, according to rule number 3, Rs must be equal to Mx. Rs must be equal to Mx according to rule number 3, but we have already found out that Rs equals to A. So from this equation A equals to Rs equals to Mx, we will derive that Mx is also equals to A. Here Mx is also equals to A. So in triangle MXN, angle MXN is 90 degrees, therefore the orange triangle, triangle MXN, is a right triangle. Therefore, we can implement the Pythagoras theorem on the orange right triangle, triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is Mn, the square of the hypotenuse is Mn square, and it must be equal to Mx square plus Xn square. According to question number 3 in Pythagoras theorem, Mn square equals to Mx square plus Mx square plus Xn square. So here Mx is A, so Mx square is A square plus Nx square. Nx is A plus B, so Nx square is A plus B square, and it must be equal to Mn square. We have already found out that A equals to 12 minus 6 times square root of 2, so A square will be equal to 12 minus 6 times square root of 2 square, plus A plus B square. We have already found out that A plus B equals to 6 times square root of 2, so A plus B square will be equal to 6 times square root of 2 square, and it equals to Mn square. Here we open the brackets of 12 minus 6 times square root of 2 square. 12 minus 6 times square root of 2 square equals to 12 square, and 6 times square root of 2 square is 72, minus 2 times 12 times 6 times square root of 2, plus 6 times square root of 2 square is 72. Here 12 square is 144, and 72 plus 72 is also 144, so 144 plus 144 is 2 times 144, minus 2 times 6 is 12. 12 times 12 is 144. So it is minus 144 times square root of 2. In conclusion, we found out that 2 times 144 minus 144 times square root of 2 equals to Mn square. We took a common factor of 144 from this equation, equation number 3. What is left from this expression of the we took from it, 144 is a common factor. What is left? It is actually 2. And what is left from this expression after we took from it, 144 is a common factor. What is left? It is actually minus square root of 2. Here we took a root out of this equation, equation number 3, and we found out that Mn is equal to the square root of 144, that is 12, times the square root of 2 minus square root of 2. Okay, so in conclusion, Mn, the distance between the centers of the circle and the semicircle, that is actually equal to Mn, is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay, the distance between the centers of the semicircle and the center of the circle, that is to say Mn, of the length of Mn, is equal to 9.18 units, or you can present it also that it is equal to 12 times square root of 2 minus square root of 2. Okay, thank you very much.